Welcome to August 20th LeetCode Challenge, Valid Sudoku. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be valid according to the following rules. Each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition, and each 9 3x3 sub-boxes of the grid must contain digits 1 to 9 without repetition. So note that a Sudoku board is partially filled. It can be valid, but it's not necessarily solvable. Only the cells filled need to be valid according to the mentioned rules. So we're given the Sudoku board, and we're just asking to see if it's valid or not. So basically, it's asking you if it's possible to basically have these three rules to be followed, and the conditions. There's some notes here telling you that it could be valid but not solvable. So we don't need to solve the Sudoku board; just need to know if it's valid or not. All right, and then we'll go into solving it. And the constraints is obviously it's a 9x9 board, and the cells are empty or space will be covered with a digit or a dot. So in order to do this, we want to find whether the three conditions are true or not. That's essentially it. We don't need to solve the Sudoku board. We don't need to do anything. We just define these two conditions are true. So in order to do this, my first thought was using a hash set. So that's let's go about solving that. Let's go do some background on it. So in a valid Sudoku board puzzle, each row and column and box itself have a digit ranging between 1 to 9 without repetition. So to check if the Sudoku board is valid for each number, we must check to see if the number is repeated anywhere else in the same row, column, or box. However, it would be very inefficient to read the entire row, column, and box every time we ask if a number is duplicate or not. So instead, we're going to iterate the numbers of the Sudoku, and then we can use a hash set to store the previously seen number in a row and column, in each row, column, or box via hash set, and then we can determine whether the current number already exists correspond to the row, column, or box in constant time. So we'll develop an algorithm to initialize a list containing 9 hash sets for basically the index of row and for columns and for the boxes. Then we'll iterate through the positions of the rows and columns. In each iteration, what we're going to do is check to see if it exists, and then we're going to update the hash set and return false. Otherwise, update the set responsible for tracking the previous number and the current index. Alright? And if no duplicates are found, then return true. So how do we go about solving that? Let's first initialize our hash set. So the first thing we want to do is let's go about defining our values. So first we're going to make n, which is a 9 length of the board. Then we're going to make a hash set for the rows, for the columns, and for the boxes. Right? And we're going to do a hash set like this, set for a cell in the range of n. I'm going to do this 3 times, I believe. Let's see. Yeah, I'm going to do this 3 times. So we're going to make 3 of it. Next thing we want to do is iterate through the rows and columns. For row in range n, for column in range n, if the board at the row and column, at the cell, is equal to the dot character, then we could continue. Because it doesn't give us any information, it doesn't tell us if valid or not, it just tells us that there's an empty space there. Alright, we Next thing we want to do is update our the number of the board. So if num, we're gonna assign num. If it's a dot, continue. If it's not a dot, then what we're gonna do is assign num to be the board at the row and column. So we're gonna assign that value there. Next thing we're gonna check is when is this false? When is this statement false? Right? When it fails one of these three. So a Sudoku board is invalid or not valid if it fails these three conditions. What are the conditions? How do we interpret that? So if num in rows are, right? If the row is inside, if the row index is kept inside the row set, hash set, or if the nums is inside the columns at the column set, or if nums is in the boxes set. And how do we know? We need to know the cell, right? So the index of the cell is going to be the integer division between, so it has to be divided by 3 times 3 plus, what am I doing? I. The row divided by 3 plus 3 times 3 plus column floor division 3, or integer division. Return false. So basically, if we already have a row that exists, a number that already exists in our row hash set, or a number that already exists in our columns hash set, or a number that exists in our our boxes, basically, and this is the index for the box number. So basically, it has to be between it's the cell, the number. Then what we're gonna do is return false, because those are the conditions that fail. So the next thing we want to do is, if this is not the case, we need to actually update our rows and columns. So row at row set number dot add num, column number index dot add num, and then our boxes at the index, which is basically this number here. Num. Otherwise, return true. Let's see if this works. Submit. Accepted. Awesome. So let's see. So the n is the size of the board, which is 9 in this question. So we can just make it generic if we want. So note that the value of 9 is fixed. So time complexity and space complexity of the algorithm can be interpreted as constant time. However, to better compare these results, we just say n to be an arbitrary value, which is like the board. So the board can be any type of input. And we would say that time complexity is big O of n squared, because we iterate through a for loop here, the rows and the column. So we need to traverse through each cell in the board, and then each of the 4 checks is so we check basically the if statements here. If it's equal to a dot, equal to r, equal to the column, equal to the box number, then that's constant time. And space complexity is big O of n squared is the worst case scenario, because if the board is full, we need a hash set to store all the cells inside the Sudoku table. So basically all the rows and columns and boxes, but the boxes are already included inside the column. So basically we need to store each number in each cell. So it'll be big O of n squared for space complexity. Alright, that's it. Have a great day, guys.